is the solution, allows you to solve problem A. Okay, I'll keep saying it different ways until you sort of help you get this concept. So it's critical for the whole chapter, right? Main idea of the whole chapter, effectively. Well, I suppose the other main idea is that you use this conversion idea, this reducibility idea, to generate proofs that other problems are unsolvable, that other languages are not decidable. Okay, so I guess they're the two main ideas of the chapter. Right. So let me try and put this a different way. To reduce a problem A to a problem B, what does that mean? It means that you convert problem A into problem B so that the solution of problem B allows you to get the solution of problem A. We'll leave it at that. Okay, so play it back a few times if you want to memorize it. Now, doing this kind of thing happens in daily life. So we'll give some analogies now of reducibility of one problem to another, so that the problem you're trying to solve, problem A, gets solved by reducing it to problem B, and you already have the solution to problem B, so that allows you to solve problem A. Well, for example, say your problem A, if you like, is you're in a new city and you're trying to figure out how to get to places, how to get around in your new city. Well, you can reduce that problem to the problem of obtaining a map. Okay, and once you so if you can do that, so the problem then of obtaining a map, you know how to do that, right? You just go and buy it somewhere, for example. Okay, so the solution to your problem B, how to buy a map, that will help you solve problem A, right? Because once you got the map, you know where to go. You solve your problem of how to get around in your new city, well, by having a map, right? So you can say that the problem of finding your way around in your new city is reduced to the problem of how to buy a map in the city. Well, you go to a newsagent or a bookstore or something that would sell maps, or some tourist centre or whatever. Okay. Now, I've said this a bit in the first square, but reducibility, you hear that term, just automatically think in terms of two problems, right? Two problems A and B. So always involves two problems A and B. So if A reduces to B, so if problem A reduces to problem B, then you can take the solution to B, and that'll help you find the solution to problem A. That's what reducibility is about. Okay? Now we will do, as we go through this chapter, we'll do case after case, example after example, of reducing one problem to another. And by the end of the chapter, you probably have a pretty intuitive idea. You'll be familiar with how to reduce one problem to another problem. And so to reduce problem A to problem B. And you already have knowledge of the solution, of how to solve problem B. And that'll help you solve problem A. Okay? Now reducibility, it's not concerned with how to solve A or B individually, separately. Right? It's about how the solvability of A depends on the solution to B. Hope that's clear. Okay? So reducibility is about how knowing how to solve B helps you solve A. Okay, but it says nothing, for example, about how to solve B. That's reducibility doesn't concern itself with that problem. That's a separate problem. Okay, hope that's clear. All right. Now a few more sort of real life examples to sort of make you familiar a bit with the concept. Although you probably got the idea, the broad idea now. So so here's some more examples of reducibilities. Say you have the problem of how to travel from Xiamen, that's the city I live in, southeast coastal city of China. It's about an overnight bus ride from Hong Kong, which is further south, so it's not too far from Hong Kong. Okay, so so your problem A, let's say, is how to get from the city of Xiamen to the city of Hangzhou. ZH in Chinese is a j, like Joe, job. There's a j sound, so Hangzhou. So that problem, A, how to get from the city Xiamen to the city Hangzhou, which is a beautiful city in China, lots of trees, and it's a very pretty city. That was where I went just recently, and in the plane, I'm pretty sure, picked up the damn flu virus from somebody. Next time I travel in a plane, I'll wear a mask, hygiene mask. Okay, so that's problem A. So how can you reduce that to a problem that helps you solve this by reducing it to some second problem B, whose solution that you know will help you solve your first problem, problem A, of how to get from Xiamen to Hangzhou. Well, that problem, how to get from Xiamen to Hangzhou, problem A, that reduces the problem of buying a plane ticket. How do you buy a plane ticket? Yes, because once you know how to buy a plane ticket, well, then you know you can get, that solves your problem from getting from Xiamen to Hangzhou, because you've got a plane ticket. So you just get on a plane, get to Hangzhou, right, from Xiamen. So your problem B is how to get a plane ticket between these two cities, right? Now that in turn, so that problem B, you can reduce to another problem, third problem, called C. So how do you reduce problem B to problem C? So problem B is how to get the plane ticket. Well, let's say it's like how to get the money for the ticket. That'd be your problem. So problem B modified is how to get the money to buy the ticket. Well, problem C then, that you reduce problem B to, might be, how do you, the problem of getting a job. See, if you know how to get a job, that will solve your money problem, okay? And so on. So, now, reducibility, I'm into the next session, so perhaps I should stop. I'll just mention that reducibility type problems occur in the context of mathematics. It may seem fairly obvious. I'll just stop there and go straight on.